Okay guys, so we have the question 5 now. So question 5 is reaction sequence type of thing, very common in organic chem. So you have ethene is the first step and you react it with HBr. The presence of peroxide? No, not in presence of peroxide. So this is your basic and Markov-Nichols addition. So you guys know what's going to happen, right? Br minus is going to come, double bond is going to attach. In fact, let's say the thing down. So first you got H plus, sorry about that. So there's a carbon here and a carbon here. Double bond is basically a bunch of electrons, 2 electrons, right? This is 2 electrons. So this carbon magnanimously donates these 2 electrons to the hydrogen, right? So donates 2 electrons to the hydrogen. So hydrogen is plus charge goes plus he got all 2 electrons. This carbon nothing changed for him. This carbon lost 2 electrons, so he gets a positive charge, right? In fact, he only lost 1 electron because one of the covalent bond, right? So 1 electron was with him. Anyways, this is basically the deal. Now Br minus is going to come. C plus Br minus is going to give Br is going to attack here. So you're going to get bromine attached to this carbon. So first step is pretty simple. You're left with what it is. Ethyl bromide. Next step says aqueous KOH. So the next step is aqueous KOH. So again, OH minus is it's a nucleophile, and aqueous KOH means it's going to probably be nucleophilic substitution reaction. So you are going to get something like OH is going to replace the bromine, right? So you're going to get something like this. Right? So you're going to get ethanol. And the last step is adding NaOH and iodine. So this is a very important reaction. It's the iodoform reaction. And if I have already told you guys that any compound of these forms, right? So let me write that down. Any carbonyl compound of this form, a methyl, anything. So you want does it satisfy 1, 2, 3, 4? Okay, sorry about this. Anything here is fine. So Y is any group is fine. This as well as compounds which look like this. So basically, you can get a double bond from an OH and an H. Okay, so everything else remains the same. Again, Y. So anything of this form or this form will react with iodine in the presence of. We'll get it from this side for the glad. Will react with iodine in the presence of NaOH to give me an iodoform precipitate, which is a yellow solid. Okay, it will also give me. You guys know, right? We did the thing. So it will give me sodium iodide. And it should give me water, I'm guessing, right? So we actually did this reaction, right? So you get 3 NaI, 3 H2O. We balance the whole thing out. Remember, 4 NaOH and 3 iodine is what you need. So this is basically a reaction works. This is called the iodoform reaction. So remember this very carefully, guys. Okay, please. You remember one of these two. Okay. Remember either the carbonyl, and remember that you can get a double bond by oxidizing this. See, NaOH and iodine, they are oxidizing. It's an oxidizing agent. Okay, so it will anyways oxidize this to this. That's going to be the first step. So I say, remember this game. Okay, remember this structure. Remember that you can also get this if you oxidize this. So this should also satisfy. Okay. One other interesting thing is you can see Y can be anything from hydrogen to any alkyl group to whatever. Remember, you only say Y as either an alkyl group or a hydrogen, basically, okay, for now at least. So if this was a hydrogen, you can see that this is ethanol, right? And ethanol, but if this is not a hydrogen, for example, if it's a methyl, ethyl, propyl, whatever, then the alcohol is not going to be primary alcohol anymore. What's a primary alcohol? It's attached to a primary carbon atom, right? If suppose I put something like propyl, right, then it attached to 2 carbon atoms, which means it becomes a secondary alcohol. So, and if suppose this was also not hydrogen or something else, it will become a tertiary alcohol, right? Now you can see that I didn't have a hydrogen here, I can never get here. So tertiary alcohols never answer iodoform test, okay? All secondary alcohols answer iodoform test. You can see why, right? Because they also have hydrogen. Okay, no, not all secondary alcohols, sorry about that. All secondary alcohols, but one of the substituents is a methyl. You need a methyl because remember, that's where you get the CHI3 from. These 3 hydrogens, instead of that you put 3 iodines, right? That's how this reaction happens. If you're having a little doubts with this, I suggest you go back and watch the Haloform video, okay? Very important. And so that's basically the deal. So you're going to get an iodoform precipitate, okay? So the only primary alcohol which answers iodoform test is ethanol. That's another interesting thing. you will see that the way to distinguish between methanol and ethanol is iodoform test. So iodoform is going to be very, very useful because it also works on carbonyls. So that's basically what I want to tell you in this question. Okay, that's the first part of question 5. The second part of question 5 is interesting. However, we've already done those questions also. So let me just check this. Yeah. So you got aniline, this compound, right? C6H5NH2 is aniline, okay? So we put the bonds. This is what we call in business as aniline. So basically, you should first ask me, well, Hari, the test sheet does not give me the structure. It only says C6H5NH2. What if you can actually have some other structure? Like, what is an isomer for this guy? And the question is, you guys should, you don't need to know this, but let me just tell you quickly. C6H5NH2, right, has something called a double bond equivalent, or in some other places they call it index of hydrogenation, okay? So IOH, or you can call it DVE, whatever, of 4. Actually, 1, 2, 3, 4. Yeah, 4. Okay, and in the business, you know that if you have any double bond equivalent of more than 4 or equal to 4, it's going to be a benzene ring. Okay, so that's just something you want to know. In fact, why don't you give it a shot and try drawing any structure which has the same formula of C6H5NH2, which is not this. Okay, so that will give you a little idea about why this is true. Or go up and go and look up these stuff. Because in future, when it comes into a lot of entrance exams, actually, they give you some random structure, random molecular formula like C8, H15, 16, or something like that, right? And you got to find out all the possible, compounds which have this, the number of possible compounds which have this molecular formula. So you can get pretty confusing, right? Because you don't know whether you can, subtract a double bond and then add something else instead, all those things. So that's where these ideas come into picture. So index of hydrogenation or double bond equivalent, whatever one, you guys should go look it up, okay? So it's interesting. Or I can save you that extra effort if you just believe me that this is the only possible compound which can exist with this formula, okay? So the first question says you add NaNO2HCl at 0 to 5 degrees Celsius. Start reaction NaNO2HCl 0 to 5 degrees Celsius. What do you get? This is basically your diazotization, right? So NaNO2HCl are going to react to form the it's a long process. You get HONO. Right? This is nitrous acid, HNO2, nitrous acid, and this is further breakdown to give me the nitrosonium ion, right? And that's why the plus is on the nitrogen. Nitrosonium ion is going to react. We do that long process which I showed you, and finally you're going to get this compound. So we put that triple bond plus minus. N2 plus Cl. Oh, oops, sorry about that. See, you can write this as N2Cl, which is basically diazonium chloride. If you want to expand N2Cl, there are two ways to do it. Okay, one is this compound has everything satisfied. This doesn't, so you get a plus charge here and a minus charge here. That's one of the ways. Or you plonk your lone pair here. This positive charge gets fulfilled, and you're left with this compound. Right. So basically, the two possible structures are actually resonance structures of each other. Here a plus here and Cl minus here. So these are the two possible structures. Anyways, benzene diazonium chloride. Okay, so you want to remember that they are resonance structures. So they are always in equilibrium. So which nitrogen has the positive charge? You never know. It's 50-50 both ways. Okay. But what you got to remember is that you got an N2 bond N, which means you got a nitrogen sitting there, which means a nitrogen, diatomic nitrogen sitting there, which means it's going to be an excellent leaving group, and we are going to make use of that. So the first compound is benzene diazonium chloride. If you guys have a doubt about how it's formed, I'd love to tell you here, but it's kind of long. So why don't you go and check out the preparation of halogens one, right? I think that's why we discussed it. So you're left with N plus Cl minus. Right? This is benzene diazonium chloride. You can also write N2 plus Cl minus. Okay. So that's your compound. Is A, and then you're reacting with CuBr, HBr. This is classic Ackermann or Sandmeyer. I keep forgetting which one. One is copper powder, one is copper bromide. Does not matter because what's going to happen is this bromine is going to come here, this nitrogen is going to leave because nitrogen is an excellent leaving group. So you're going to be left with nitrogen gas plus bromobutane, right? So that's basically Sandman reaction. In fact, you will also be, since there's a chlorine here, you have copper here, you will be left with CO. What's the oxidation state of this guy? 1 does not in reduction, so COCl. Right? So these are going to be your products in balanced in whatever way. In fact, it's perfectly. It's not because you have a H here. Okay, so it's going to be, if you balance it out, it's going to work out, so don't worry about that. Anyways, this is what you're going to get. This is your compound B. Okay, we're talking about many compounds of organic compounds. So that's going to be your compound B. And I think the next reaction is you take that and you do this famous reaction. So you take bromobutane, okay, and you're gonna do FNC acylation, Friedel-Crafts acylation. So you guys should be familiar with that. We did some questions on that. So CH3, COCl in the presence of anhydrous FeCl3 or AlCl3, whatever. So this is acylation. So you guys need to tell me what the product is going to be. So I'll give you a few seconds. If you want to always not go wrong, because it's kind of hard to memorize these, I agree. So the best way to not go wrong ever is to actually know the mechanism, right? So the mechanism, what basically happens is you have CH3, COCl, right? And you have FeCl3. Now this iron is highly deprived of electrons because 3 chlorines are sucking electrons out. So this guy is going to donate, okay? And then what's going to happen is chlorine is going to like iron a lot more, so it's going to take this bond. Okay, so I'm just telling you very quick. I'm not going into the details. So what's going to happen is you're going to be left with FeCl4 minus and this. Okay, so this is going to be your electrophile, right? And now what's going to happen is, as you can see, there can be one more structure to this, right? So there's lone pair and oxygen, so we can donate, and I can also get CH3 C triple bond O plus. And the interesting thing is that if you actually look at this solution, this resonance structure is much more predominant than this resonance structure. And if I have not already told you why, the reason is because in this all guys are enjoy octet, okay? Although oxygen has a positive charge, which is highly unfavorable, all guys enjoy octet here. In this case, carbon does not enjoy octet, okay? So since all guys enjoy octet here, it's going to be much better. However, the attacking specimen is going to be here. So since carbon has the positive charge, it's going to attack. Now, where is he going? So this is the electrophile. So once you find the electrophile, the next step is where are you going to attack? You have 5 positions here, right? Bromine is a halogen, ortho-paradirecting because of the plus R effect. However, he is also minus I, so technically these the ortho positions are actually a little electron deprived also, right? Because although he gives electrons this way, he takes them back because of his electronegativity. Para is going to be unhampered because of the fact that bromine is so far away. So only the plus R effect is considered. So you're going to have maximum electron density here. This guy is a positive charge, he's going to go towards maximum electron density, right? So you're going to be left with, he's going to attack here, you're going to be left with this compound. Deprotonation occurs, blah blah blah, the long process. Bromine. Remember the carbon has a positive charge, so carbon, double bond of CH3. That is your compound. So that is your compound number C. Okay, so this is basically the reaction. This kind of tests if you are good at all different kind of levels. So it's a good question. Why don't you guys take a break and we'll do question 6 in the next one. See you.